Hello everyone. In this video, we will cover the curtailed expectation of life. This is a similar concept to the complete expectation of life, except that we are working with the random variable kx. The symbol for curtailed expectation of life is ex without the circle on top. So ex is ekx, the expected value of kx. So this is the summation k times the probability kx equals k from 0 to infinity. If there is an upper age limit, then the upper limit becomes omega minus x minus 1. This is the maximum complete number of years for an individual at age x. All right, the probability that kx equals k is k bar qx, and we can rewrite it as kpx minus k plus 1 px. The first term, when k is 0, the term is simply 0. So we start with k equals 1. So here, the first term with k equals 1, we get 1 times px minus 2px. The second term, 2 times 2px minus 3px, etc. And then simplify this expression. For the terms px, we simply have 1 times px. And then the terms 2px, we have 1 times minus 2px plus 2 times 2px. So this gives 2px. And then the next term, we have 2 times minus 3px plus 3 times 3px. So we get 3px. And this is the expression for the curtailed expectation of life, the expected value of kx, which is the summation of kpx, k equals 1 to infinity. How about the variance? First, we get the second moment of kx, the expected value of kx squared. By definition, this is the summation, k squared times the probability that kx equals k. The same expression. And then the first term, k equals 0, this expression is simply 0. So we start with k equals 1, we get 1 squared px minus 2px. The second term, k equals 2, we get 2 squared, 2px minus 3px. And then the general term, we have k minus 1 squared, k minus 1 px minus kpx, and then plus k squared kpx minus k plus 1 px. The coefficient for the term kpx is the negative of k minus 1 squared plus k squared. Simplify this. This is 2k minus 1 times kpx. All right, so we can simplify the expression above. We get px plus 3 times 2px plus 5 times 3px. The general term is 2k minus 1 kpx. And this equals the summation, 2k minus 1 times kpx, k equals 1 to infinity. This is the expression for the expected value of kx squared. And from that, we can get the variance. And then we have similar expression for the n-year temporary curtailed expectation. We simply replace the infinity by n. And then the notation for the n-year temporary curtailed expectation is ex angle n, which is the expected value of the minimum value of kx and n. All right, so let's take a look at some examples. Given the following, Q80 is 0.3, Q81 0.4, Q82 0.7, and Q83 equals 1. Calculate E80 and the variance of K80. Since Q83 equals 1, so we have a limiting age. The limiting age is 84, so omega equals 84. So we have an upper H limit. So Ex equals the summation of Kpx from k equals 1 to k equals omega minus x minus 1. And omega is 84. And we want to get E80. So x is 80. So we only need to sum up the terms k equals 1, k equals 2, and k equals 3. Only 3 terms. All right, Kp80. So this is P80, 2P80, and 3P80. We get the 1-year period mortality probability. So P80 is simply P80, 2P80 is P80 times P81, and then 3P80 is P80 times P81 times P82. So we get this probability by taking 1 minus the cubes. And we get E80, 1.246. And how about the variance? The expected value of kx squared, which is the summation of 2k minus 1 times kpx, where k equals 1, upper limit is omega minus x minus 1. All right, so we get the expression 2k minus 1 of kp80, k equals 1, 2, and 3. Substitute the numbers, and we get the second moment, 2.59, the expected value of kx squared. And then the variance equals 1.0375. The next example, given that a force of mortality mu x equals 0.035, and we are asked to calculate E55, the current expectation at age 55. All right, we start with the definition. This is the summation of Kp55 from k equals 1, and there's no limiting age, so up to k reaching infinity. So we need to get an expression for Kp55, which is e to the power negative the integral of the force of mortality 0.035 t from 0 to k, which is e to the power negative 0.035 k. So we have P55 plus 2P55 plus 3P55 and onwards. And we have an expression for Kp55. So we simply substitute k equals 1, k equals 2, etc. into the expression for E55. And this is a geometric series. Upon calculation, we get 28.0743. All right, the next example involving the given force of mortality, and then ask about the 4-year temporary curtailed expectation at age 70. Okay, the definition, the summation, Kpx, k equals 1 to n. This is the temporary curtailed expectation. So the upper limit here is n. So n is 4. And then we need to get an expression for Kpx or Kp70. So as usual, the definition of Kp70, this is e to the power negative of the integral of the force of mortality at age 70, 70 plus s, where s from 0 to k. Upon calculation, we get Kp70 equals this expression, 71 over 71 plus k, and then squared. Once we get Kp70, then the rest is straightforward. the summation of Kp70 for k equals 1 to 4. And then we simply plug in all these p's into the expression Kp70 for k equals 1, 2, 3, and 4 respectively. So the first term when k is 1, so we have 71 over 72 squared. And then the second term, 71 over 73 squared. Until the last term, upon calculation, we get the answer 3.7351. And this is the summary regarding the formulas of the complete expectation and the n-year temporary expectation, as well as the current expectation and n-year temporary current expectation. You can see the similarities between these two sets or these four sets of formulas. All right, that's it for today's video. In the next video, we will do the recursion formula for the current expectation of life. Thank you and see you in the next video.